Now in this question, we have a system of linear equations, and notice they're both already in standard form, which may make you think, okay, solve systems would be a great program to use, which I appreciate you thinking that way. However, something I do want to point out, notice on our triple T document for the math section, the first tip says, don't look at the answer options right away, they'll only confuse you. However, it can be useful to look at the answer format. And when we look at the answer format, we can see that a couple of the options are actually infinitely many solutions, no solutions, which we call the special cases. And they're not actually asking for the solution. They just want to know the number of solutions. Now, something that's good to know, you really, with a system of equations, you can only either have no solution, one solution, or infinitely many. So you're really never going to have option D here. But I want you to notice if we do go into solve systems and we type in the coefficients of 6, 2, 3, and then for the bottom equation 6, 1, since there's nothing in front of the y, we assume it to be a 1, and then 3 again. In this case, we did get one solution. It gave us an actual ordered pair. However, if it was either no solution or infinitely many, it would have just come up with this error message instead. And that error message could either be no solution or infinitely many, so it wouldn't be as helpful as in this case using Desmos. So let's go ahead and check out Desmos together. And before we do so, let's go to our math reference document. So you can see on the back of page 33, which is side 2, notice the 3 different scenarios for 2 linear equations. So if you have different slopes, the lines are definitely going to intersect at some point, and you can only intersect at one point at most when they're 2 lines. So that's the one solution case. However, notice if the slopes are the same, you could have one of these 2 special cases. If the y-intercepts are different on those 2 lines, then you know that they're never going to intersect, and so we say that there's no solution because there's no point of intersection. If, however, not only are the slopes the same, but the y-intercepts are the same as well, then we know that there's going to be infinitely many solutions because it's going to be the same line on top of itself. So they're going to have every single point in common. So now let's go ahead and choose Desmos, which is in the upper right corner in our software, as well as in the actual digital SAT platform called Blue Book. If you have any equations already from a previous question, you click on this gear icon, you click delete all, and then we're going to go ahead and type in our 2 equations. So I might need to have to shift around here. And we're going to go ahead and type these in. I like to just type them in directly. You could choose to use the keyboard that they provide. I'm just a little bit more comfortable with my own keyboard. And we'll go ahead and type these in. So we have 6x plus 2y equals 3. I'm going to press enter and do 6x plus y equals 3. And then let's go ahead and take a look at what we have here. Well, you can clearly see that they're intersecting. It doesn't really matter what that point is. If I wanted to know it, I could click on it. It looks like 1/2 comma 0, which is the same that we got, which again means that we have one solution, making the correct answer option B. Now, if you are curious what to do if you were doing it by hand, I just want to be thorough and make sure you feel comfortable, especially for your own math class. I would definitely be doing elimination in this case. And if we go back to that same page of our math reference document, notice here, substitution versus elimination. Substitution really makes sense if either a variable is already isolated, like in this bottom equation, or if it can easily be isolated, which that means if there's a coefficient of 1 or -1, because then you won't get any fractions when you isolate. In this case, if they're both in standard form, or none of the coefficients are 1 or -1, then elimination definitely makes more sense. So that's what we have right here. They're both in standard form. So the way elimination works is I'm going to try to eliminate one of the variables. In this case, I already have this top one and bottom one both having a coefficient of 6. If I just multiply, let's say, the bottom equation by -1, it's going to make it so that the coefficients of x are opposites. And then when I add them, they're going to eliminate, hence elimination. So we'll go ahead and flip all the signs of the bottom equation, add vertically, and we get positive 1y when we add those 2 y terms equals 0. So we got y is 0, and then at that point you can plug that back into either of the other equations, and you'd get 6x plus, replacing the y with 0, the 0 really does nothing. So I'm going to go ahead and divide by 6, and we get x is a half. So we get the ordered pair. Now, if instead it was no solution, the way you would know that is if both the x's and y's canceled, and you would get 0 on the left side. And if you get a true statement like 0 equals 0, that's infinitely many solutions. If you get a false statement like 0 equals 5, which isn't true, then it'd be no solution. But in our case, we got exactly one solution, making the correct answer B.